Okay, the objective today is to connect visual models with the distributed property to partial products and the standard algorithm. The difference between today and yesterday, this is with renaming. Now, personally, I like doing the models without renaming, but the standard wants you to know both, so we're going to do both. Okay, so we're going to go ahead and draw our area model. This time when we do our area model, we're actually going to rename or break them down further. Yesterday when we did it, we were not doing it by place value. Today we are going to do it by place value. So there's 527 times 36. And over here we're going to do our standard algorithm. 527 times 36. Now the first thing in your standard algorithm would be 6 times 7, which would be 42. So you can see in here 6 times 7 is 42. Our next would be 6 times 20, which would be 120. If you notice, I am making sure when I line them up, I'm lining them up at place value. 6 times 20 would be 120. Our next, we still have to do the last 6. We got 6 times 500. And 6 times 500 is going to be 3,000. 6 times 500 is 3,000. Our next, since we're done with our 6 now, we're moving to our 30. And this is 30 times 7. Over here you can see 30 times 7. 3 times 7 is 21, and add our 0. So we end up with 210. Well, we did 30 times 7. Now it's 30 times 20. But we know 3 times 2 is 6 and 2 zeros. 30 times 20, 3 times 2 is 6 and 2 zeros. Our last one is going to be 30 times 500. And this is the last block. We know 3 times 5 is 15 with 3 zeros. So we end up with 15,000. On my standard algorithm, I'm add them all together, and I can see I have 2, 6, 7. There's 8 and 9, 18. So I end up with 18,972. As far as the standard as far as the area model, when I add these up, I know I have 18,000 in this column plus 720 plus 252. So when I add these up, I have 18,720. So that means I got 18,720. Now I'm going to add the last 252, and I have 27981, 18,972. Okay, so we're going to start off with our standard algorithm with renaming 649 times 53. And we're doing the partial product, so we know this is 3 times 9, which is 27. And then we got 3 times 40, which 3 times 4 is 12, and 0 is 120. Now we have 3 times 600, and 3 times 6 is 18 and 2 zeros. Now we're done with our 3, so now we're moving to our 50. We have 50 times 9. Well, I know 9 times 5 is 45 and a 0. Now next one we have is 50 times 40. Well, I know 5 times 4 is 20 with 2 zeros. So that's going to be 2,000. Make sure those are zeros. And the last one we have is 50 times 600, which I know 3 times 5 is 30 with 3 zeros. So there's 1, 2, 3 with 30. Now we're going to add them up. We end up with 7, 2, 4, and 5 is 9. And then we have 8 and 1 is 9, 10, 11, 12, 13, and 6 is 19. Let's count that again. That'll be 9 and 3 is 13. Here are 1, that's 1, 2, and 4, and a 3. So we come up with 34,397. Now let's go to the standard algorithm without renaming to check ourselves, because there's always a chance for error when you're doing the partial products. 3 times 9 is 27. Here are 2. 3 times 4 is 12, and 2 is 14. Here are 1. 6 and 3 is 18, and 1 is 19. So we have 1947. We're going to put our 0 in there, and 5 times 4 is 45. 5 times 4 is 20, and 4 is 24. 6 times 5 is 30, and 2 is 32. We add them up, we got 7, 9, 13, carry 1, 4, and we got 34,397. And we can see the standard algorithm without renaming is a lot more efficient than the one with renaming. Okay, each of the 25 students in Mr. McDonald's class sold 16 raffle tickets. If each raffle ticket costs $15, how much money did Mr. McDonald's class raise? Okay, so if I were to draw a tape diagram on this, it would be a two-step problem. First one, I know that each student, and this is one student, okay, sold 16 tickets. And I know that there are 25 students. So to solve out how much tickets they sold, it would be 16 times 25, which would equal total tickets. So let's go ahead and do that. 16 times 25. I'm going to use the standard algorithm. 6 times 5 is 30. Here at 3, 5 times 1 is 5, and 3 is 8. Going to our 20, we're going to put our 0 down. Now we got 2. 2 times 6 is 12. Here are 1. 2 times 1 is 2, and 1 is 3. So we can see we have 400 tickets. Now, here I have each ticket is $15, and I have 400 tickets. So total cost is going to equal 15 times 400. So I'm going to put the larger number on top, 400 times 15. 5 times 0 is 0, 5 times 0 is 0, 5 times 4 is 20, so we have 2,000. Now we're done with the ones place, moving to tens place, but we're going to put the 0 down here so we can just do our basic math facts. 1 times 0 is 0, 1 times 0 is 0, 1 times 4 is 4, and we can see that it costs $6,000. So total cost was $6,000. Now if I wanted to check this, I would do reverse operation. So let's go ahead and take 6,000 and we're going to divide that by 15. 15 will go into 60 4 times. 4 times 15 is 60. Subtract what we used, bring it down. We have to bring down our next digit. 15 can go to 0 0 times. 0 times 15 is 0. Bring down our next 0. 15 would go into 0 0 times. So we can see we ended up with the same amount of tickets. It was 400. Now to check the 400, we come back over here. We got 400 divided by 25, and we should get 16. 25 will go into 40 one time, and 1 times 25 is 25. And that gives us a remainder of 15. We regroup into ones. We end up with 151s. 25 will go into 151s 6 times. 6 times 25 is 150. We end up with 0. And you can see we're back